So today I'm going to create a sort of a web page that will solve a Sudoku game, and create a visualization around how it solves it. So for those who don't know what Sudoku is, I will try to give a brief explanation about it. So on this screen you will see a sample Sudoku game. So Sudoku is a game, it's a 9 by 9 grid filled with numbers. The goal is to fill it completely with numbers, and it has some restrictions. So there are three restrictions basically. The first one is called the box restriction. For example, this is a box. In one box, you cannot repeat a number. So if there is a 6 here, you cannot have a 6 here, 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 or here, or a 9 or 8 or 5 or 3. So this is one of the restrictions called the box restriction. Another restriction is the row restrictions. For example, this is a row. So in this row, you cannot repeat a number. So if there's a 5 already here, you cannot have a 5 here, 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 or here. And another restriction is called the column restriction. So in each column, for example, this is a column, you cannot repeat a number. Basically, in all three restrictions, whether it's a box, a column, or a row, you cannot repeat a number in that. So in these restrictions, you have to fill the 9 by 9 grid with numbers in such a way that no number gets repeated in these three restrictions. And the numbers you can use are only 1 to 9, so no two-digit numbers. So when you give a computer a grid of 9 by 9 numbers and tell it to solve it with Sudoku restrictions, there are many ways it can accomplish that. But one of the simplest ways is to do it using backtracking. So backtracking is a method, it's sort of like a brute force method. But in backtracking, what the computer does is it tries every possible combination. And if it doesn't work, it goes back and does some small changes and proceeds forward until it finds a good solution. If no solution is possible, it will return an error. So what I'm hoping to achieve today is create a web app that will do backtracking and show how it's done. I have done this before and I already have a YouTube video around it to show how it works. So this is what the end product will look like after today's stream. I made it, I think, 1.5 years ago. So we are going to make it again today, but it won't look as nice as this, but hopefully it will look close enough. So I think we should start. I will make it in simple HTML, CSS, and JavaScript so that even beginners can follow it. For starting, we will create an index.html file. It's a basic index.html file with all the basic data. I hope you can't hear my keyboard this week. Last week, my keyboard was very loud. Okay. So I will start a web server so that we can view what's happening. So we will preview it here. So to start, we will create a grid of a 9 by 9 grid. So we'll create a div, and in that div we will create, I think, 9 by 9 81 more divs. So for each and in each div we will create an input. Also, because each div will only have one digit, we will use the attribute max length is equal to 1. So it's here, but we need 81 of these. I think the easiest way to create these should be div times 81. Div input. This will work. 81. Okay, this will work, but I need to add an attribute. Let's see. I don't remember how Emmet works for attributes. We have to take it up to Emmet. We need to add a match length attribute to it. Okay, line multiplication and grouping. Something about attributes here. Okay, div ID and class. Okay, and custom attributes. Yes, I need to do something. Hello, Heather. Are you here? Please speak loud. I have deliberately kept the volume low so that background noise doesn't appear. So we will add an custom attribute called max length, and we'll keep this value 1. Okay, and I think I'll add a class that is called cell. It will help in styling it later on. Yes, it worked. I think I will have an additional one that I will delete. So now, as you can see, I've got 81 inputs. Now we need to style it and make it appear in a grid format. Okay, so I will add an ID to this grid so that I can style it in the CSS and add an CSS file. Okay, I will link CSS here. Index of CSS epic ID dash I. So we have gotten 81 inputs here. Now we will style in the grid format. So first of all, we have linked the index.css and now we will style the grid. So that the grid will need to have the display of a grid and the template. We'll use the grid column templates. Will be a repeat of 9 elements. We need to pass the bits as well. Let's say 10. Weights, the weights of the grid will be, I think 9 rated is let's see it's linked correctly. Why is it styling properly? Displays correctly. I think instead of live server, the wrong value here. It should be something. And will this work? Yes, it worked. And it will 90 px. Something. I think I'll increase the weights first. So I think 80 pixels wide should be enough for the grid. I think it's better if I define a variable for this. Let me keep track of it later on. Box 80 px. You can use file system. File system is good for this project, but it can create problems later on, especially while linking to different CSS or JS files, because the file paths in the file protocol act differently than they act on the HTTP protocol. Okay, so we have the variable set, so we'll calculate the variable here. The same variable, calculate 9 into variable. So we have got a basic grid. The last one is, I don't know what the problem is with the last one. I know that, but it is easier for beginners. Well, maybe, but it can create confusion for beginners later on when some linked file does not work properly. So let's see why this isn't working. Okay, I think it will resolve itself later on. So we have got a basic grid here with 9 by 9, a 9 by 9 grid here. We should style our cells also. So as you remember, I added a cell class to it so that I can style it easily. I will add a border to each cell. Okay. and width and height also. So we have already defined the width and height, so we'll use that to make it a box. So now it's looking good. Not good, but the input designs, I will need to disable the styling of the inputs. So I will styling of it. And why last one is looking bigger? The last one is looking bigger because it's the input styling. Hello Weber. So I will remove the styling of each input so it will look normal. So it should not, the input should not have a border. Okay. It shouldn't have a background as well. Now it's looking proper. I will also give it the same height and width as the parent. Height and width. Okay. So we need to increase its font as well. Font size. I think this should be, yes, this looks good. We align the text to center. Okay. I think this slightly maybe padding. Yep. It looks fine now. So we have got the font size, padding and text length, and they should work well, I think. We'll disable everything later on. So, okay, this is good enough, I think. Let's center it to the web page. Into this. So now it's under the container class, and I will style the container. Hey Epic, can you tell me if my keyboard is making noise today as well or not? Because I did some settings and I changed the location of my mic, so hopefully it's not as noisy as it was last time. Okay, so now we have got a container. We will use display flex for it so that I can easily center it vertically and horizontally. Okay, I have a column and I will justify it. Justify context. Okay, let's add a title. Okay, this is good. Let's center itself, I think. Next column, justify context into textualize. The grid has a margin that I need to remove. I will add some margin, it will center itself. Yep, centered itself. Okay, no sound. Okay, that's good. Now we have got a basic grid, a 9x9 grid. And now, yeah, I don't think we need to add anything else right now. This should be enough for right now, and we'll start coding the JavaScript. So we have got a basic 9x9 grid. And now we'll start adding some basic functionalities to it. So let me create a JavaScript file first. And let me link to it somewhere. I prefer linking it. Okay. So what should be the first thing that we do? I think the first thing that I will do is get all the inputs. So let all inputs query selected. All of them are in the cell. And all inputs should be an array of all the inputs. And I want to restrict each of them to a number only. So since this is not a form, I won't be using client-side validation for this. I will need to prevent this from using JavaScript on the key down event. all inputs for each input. Add an event listener. That will be the key down. Coming back in a minute. Okay. So on the key down, we will need to disable. We won't handle the key down if what condition should we add? I think we'll start with that with basic condition. If e dot key is less than 1, or if e dot key is greater than 9. Which so will prevent it from. So now if I type any letter, it can work. Only letters will work. Okay. Yes, I think this is good. So this will prevent or allow numerical values. Now since this is done, we will create a button that will start the solver. Okay. So we will add a div somewhere with controls below the grid. The grid one, I think. Below the grid should be fine. Okay. We will add a button that says we give it an ID of. This will start our Sudoku solver, but we haven't written any code for solving the Sudoku. So what should we do? Should we write the code to solve the Sudoku first? I think that should be the first thing that we do. We'll create a new JS file first because we will be out of code. So we have got a new file called Sudoku, and we'll create a class called solver Sudoku unit. Now we have a class called Sudoku, and when we start this Sudoku, we will get all the inputs. So we can use this. We've got all the stored in a variable called inputs. Okay, so now we have got a Sudoku solver with the inputs. So what functions does a Sudoku solver need? First of all, we'll need a function that will solve this. So we'll create a function called solve. So we've got a function called solve. So like I said before, to solve a Sudoku, it uses backtracking. In backtracking, it is necessary that we will check if the constraints are creating a problem for the number or not. So if it's safe to use that number or not. So to do that, we will create some functions that will return the. How should I do this? There's only one viewer remaining. I don't know who is it. So let's think. Let me think a bit about this. So we've got a Sudoku solver. So I know how the Sudoku solver works. Let's start by keeping track of an index. And I think it should start with the 0 index first. And for each index, it will check if it's safe to use a number there or not. So we need to create some function that will check if it's safe. So we'll create a function called check. It will check if it's safe to use a number there or not. For that, we'll get index and value. So on which index and which value to use, it will check if it's safe to use that value or just an arrow here. We have got a check function as well. So to check, we will need, or to check an index, we will get the value from the index and compare it with the value in its box, index or in its column. Okay, so we'll need a function to get the box indexes. So we'll create a function called get box indexes. I think it's indices. Maybe indexes for an index value. The box indexes for any index value, the 8 cells around it. Oh no, not the 8 cells around it, but the index of the box in which it's present. So it will have array called indexes in which we'll push the indexes, and we'll need the row and column of the index. So we'll need to convert the single index into the row and column. So I think I will use a function called, so it's a one-dimensional index and we are going to convert into a two-dimensional index with a row and column. So we'll call it a function that we call get 2D index, and it will take an index value and return the row and column. So the row will be and since we have got 9 rows and 9 columns, we will need to divide it by 9, and the column will be index normal. So how this works, for example, we have got this will be index 0, 1, 2, 3, 4, 5, 6, 7, 8. This will be 9 and this will be 10. For example, we have got index 10. In rows and columns, it should be the first 0 in the first row and 0 in the first column. So if we do 10 by 9, it will return 1. And if we do 10 mod 9, it will also return 1. So this is how it works. For example, we have the 11th index. So it should be the first row and the second column. So we will again do 11 by 9, which will again return 1 after being flowed. And it will return 11 mod 9 will return 2, which will be the column 0, 1 and second column. So this is how this get 2D index function works. So now we have got the get 2D index function. We will get the row and column from this. Get row comma column is equal to get 2D index. This dot get 2 index for this index. Now we have got the row and column. So now that we know the row and column, it will be easy to calculate which box it is in. So first of all, let's get the starting base row. For this base row will be equal to row by 3. So for example, we are in the 0, 1, 2, 3, 4th row. For 4th row, it should return 3. 4 by 3 will be 1. I think I should multiply by 3. So 4 by 3 is equal to 1 and 1 into 3 is 3. So it returns 3. For example, I am in, let's say, the 7th row. So for 7th row, it returns 6. So 7 by 3 is 2 and 2 into 3 is 6. Yeah, this works. Similarly, we'll write a variable called base column and column by 3. So for any row and column, it will return the base column and base row. So the base row and base column is the starting row and starting column of that box. Now that we know the base row and base column, we will iterate over it. That I is equal to 0, I is less than 3i plus plus, and for let j is equal to 0, j is less than 3, plus plus. So we will go from 0 to 2 and 0 to 2, and we will add those to the indexes. Indexes, but the indexes dot push is using the 1D array, so we need to convert the 2D coordinate into the 1D coordinate again. So we'll use data function called map 2D that will take the row and column and map it to the one dimension, the single dimension. So it's a simple formula. It will do row into 9 since we have got 9 columns, and add the number of columns to it. This should work. Now we have got called map 2D to the row base row plus 5 and base column plus j. Let's see if it's working right now. I will link Sudoku. So in the console, I will create a solver without, yes, I got a new keyword, new Sudoku. So now we're going to solve it variable and we'll get box indexes. So for example, for the 0 index, oh, I forgot to return. See. Right now. Okay, so for 0 it's saying 0, 1, 2, 9, 10, 11 and 18, 19, 20 all the blocks. Yes, that's correct, but we don't need the 0. We need to check itself or it will create issue, so we need to skip that. Okay, so let's start that 2D. Let temporary will store this result in a temporary variable, and if this temporary variable is equal to the index we are checking, it's not equal to, we'll push the index, we'll push the temporary index. So this should work now. It skipped the 0 index. So with this function we will get the box indexes for any index, will get the indexes of the box around it. Similarly, we need to create a function for the row and for the column as well. Get row indexes for the index. They should be much simpler than the box function. So again, we'll create an indexes array, and I need the row. So again, I'll do red row from a column with this. The 2D, I'll convert the index into the 2 dimensions. Now I've got the row and column, and here I need to iterate over both rows and columns, but here I need to iterate over only the row. I will need to get only one for this. Let I is equal to 0, I is less than 9. I will again create temporary variable let temp is equal to base.map to. I don't have a base row base column this time, I only have the row. And yes, the row will remain the same, only the column will change. The temps will just okay. Now if temp is now equal to index is dot push. Sorry, I'm a bit late. No worries, Mayank. So I have created a grid with the HTML, a 9x9 grid, and now I'm writing the function to solve the Sudoku. Solver dot get row indexes. So for example, we are at the first. Oh, I forgot to return again. Okay, so for the first row, for the first index, if 0, 2, 3 is working nicely. We'll create again a similar function for columns. Get column indexes, but here instead of row comma I, it will be I comma. Get column indexes for, let's first index. False not defined. Where did I use false? So 10, I suppose, I think 10 means this, 10 is 8, 9, 10, 19. Yes, I think this is also. So we have got our 3 functions. The box index will return the indexes of the cells in the box. The row indexes will return the indexes of the cells in the row. And the column indexes will return the indexes of the cells in the column. So by using these 3 functions, we'll check if we'll write these 3 functions to check if it's possible to use the value on that given index. Okay, so for this given index, let the box index will be equal to this.get box indexes index get row index indexes. We'll get row indexes index. Let column index will be. No, I don't think I missed anything good. Get column index. So for any index, we are going to get the indexes of the box, cells in the box, cells in the row, and cells in the column. Now we'll need to iterate over all three of them and check if any cell in the box, row, or column has this value. If it doesn't, we will return true, and if it does, we'll return false. So we'll keep a flag variable for this. So after this, we'll iterate over the box indexes first. Box indexes dot for each index. So we need the value as well. So we'll get the value at that index. We have stored all the inputs in this dot inputs, I think. This dot inputs, and for that given index, we need the value. And if that value is equal to the value that has been passed to the function, then we will return the flag false. Similarly, we will do the same thing. Let's check it's working first. So for example, I will store 2 here. Check. So I need to check if at the 0th index I can have a 2. And got type error reading 1 at 49.22. So line 49.22. I think I know what the problem is. We'll need to convert it into integer. So if I have 2 here, and I need to check if I can place a 2 at the index 0, reading 1. I'm converting into the value, okay, for each index. If Oh, I think I know what the problem is. I haven't passed the inputs to this. I think we need to just see if we can pass the inputs. Okay, we have got the start button here. Let's use that. Button. Get ID button and add in button start button. We'll add an on click listening to the button start. It's called a click, and in the click we'll add a callback function. That will create a new Sudoku solver. Solver with a new Sudoku. But we need to get the inputs first. So we pass the call. So I hope this works. And once we have the solver, what do we do with the solver? And the solver global variable, so we can use it. Okay, give me a second. All right, I'm back, and I will. Okay, I'll try to speak a bit louder. So where were we? So we have got a solver, and we have made a global variable. So let's see. We'll create a solver with. I think I will have a solver variable, and let's see if we can. Can that run? Check. Screen is blurred. Oh, sorry. Is it fine now? So I think it will be difficult to test it while it's in the computer. Let's finish this first. So my logic is if any of these matches the value, will the flag falls. Oh, I think I'm not returning it. To return the flag after it's done. So we are checking the box indexes. We will check the row indexes as well in the similar manner, and the column indexes as well. I think there's some background noise here. So now that we are checking for everything, I think they should be fine. Sorry for that. Somebody switched off my lights. So this will return the flag if it's. I think we're going to check something. Check what should work fine now. Let's try the solve function. So first of all, we will check if the index. How should we do it? First of all, what we can do is when we click the solve button, we will disable all the starting inputs. We will disable all of them, so that once we start solving, we'll know which inputs were there from the start. So here's a input start for each, I suppose, or for each input. For each input, if the input has some value, we will set it attribute this. For example, if we have this start and this will get disabled, so that we will know this value was there from the start. Okay, so now we have got then initialize the solver and then we'll start solving it. Okay. I've got 2 errors right now, that's good. I'll bring the mic a bit close to me. So whenever the solve function is called, we'll first check it that we put it disabled or not. So if this dot input and this dot current index, we get attribute. The autocomplete is not working, but if it's disabled, if disabled, we'll move on to the next index. So we will increment the current index by 1. So increment the current index by 1 and we will stop the function. Okay, so now that so if it's not disabled, then we will need to check if what its value is. Okay, so value be equal to this current value. Now we have the value, we'll check past. Now we have the value inside the box. If the value is 9, that means if it's at the end. I don't need to worry about that right now because we need to reverse it. Yes. Increase its value, just dot current index dot value is equal to value plus we just implement it. Okay. See how this works. So we have got 2 here and we'll start. We have click solve, so why didn't it solve? Let's see if it's switching the value correctly or not. Do we have a current index somewhere? Yes, we have got the current index set to 0. So if we put oops. So if we put 2 here and select start, something got logged. Yes, it's getting logged. Something is broken somewhere. Let me check. So this is working because this got disabled, and then you got a solver with the solver dots. It's running. I think I'm in the wrong place. Okay, yeah. Sudoku solver is not defined. Okay, so that's why I can't use a solver to ensure the entry is right or wrong. This is, so now it should work. Start. Sudoku solver is not defined. Okay, the Sudoku is the name. Okay. Okay, so not a number. Yeah, I can't use a solved Sudoku to ensure that the entry is right. Which solved Sudoku are you talking about? Since it's not a number, I think it's because here we'll or a 0 if there's nothing present. So if we do 2 and start, it will do 1. Okay. So what next? If we do solver dot solve again, move one step ahead, solver dot solve. Yes, it will keep moving. We still need to work a lot on this. It's working to some extent, but first of all we'll need to add a check. If it's 9, value is equal to 9, we need to reset its value. First of all, we'll delete whatever is in this value. This is the correct index dot value is equal to, and we will decrement the correct index. We go one step back. We need to keep track of which direction we are traveling in, so we will create a variable called direction. So depending on the direction, we'll move. So the first direction will be positive because we're moving ahead. But if we encounter the value 9, we will reverse the direction. And if we reverse the direction, we need to come back as well. So if it's not disabled, then we're moving ahead. Direction, I think they should work. So if I start with this, and then do solver not solve 3, 4, 5. Because something is still wrong, but I think it will fix itself as we keep making this. So okay, I think this code is probably good enough for now. I think if the value is not sit, that's I get the error there. So what else do we need to do? We are incrementing its value, but we will move ahead if this value is correct. That means it's safe to use this value. If this work for this current index value, if it's safe to use this value here, we'll move on to the next index. I think this was the code that we're missing. Now if we'll start with the 2, 1 works, so it will move on to the so 1 works, so it will move on to the next index. Here 1 does not work, so we'll increment to 2. 2 also doesn't work, so it will move on to 3. 3 works, so it will move on to the next. So yes, so it's working correctly. We just need to refine it a bit more. I think I will add some sort of method that it will populate the Sudoku itself. I don't want to type it again and again. We will use this example to start. Sample. Okay, so this is 5, 3, 0, 0, 7. I should have example somewhere. Yes, I have this written down already, so we'll use this. This is the same example. Yes, so we'll use a sample to test out our program. We'll need to input this sample data function that will create a function called test. Test. So what we will do is for data is equal to 0. Is again j is equal to 0. J is less than 9. J all inputs. Map 2D isn't a function here. We need the map 2D function. So map 2D. We'll move it out of the Sudoku class because we need to use it other map 2D will is it map 2D? Map 2D. We will map I comma j. We'll create a singular 1D index and we'll set its value to the value given in our test as a sample I j. Okay, let's see if this works. So if I execute test that function populated, but we don't want 0 0. So if it's equal to 0, set its value to empty. So if I call test app now, it will populate it itself. And if we start it now, keep on solving it. It should 1, 2, 3 does not work, 4 does not work. I think there's an error. This dot get 2 index, yes, we removed that. Get 2D index not in this anymore. Map 2D is also not present in this anymore. So now it should be fine. I call test that and then keep on solving it. Solver.solve. I haven't started it. Now I've started it. Okay, so 1 works here, 1 does not work, 2 works here. It's slowly solving itself. Let's see if it encounters an error somewhere. Sort of working. Okay, let's keep working on this. We are making good progress. So first of all, I think I will create a way that I don't need to solve it manually. So where we have a start button button will keep on solving it itself. But till when? Let's keep a variable called running. Let running. Let's keep track if it's running or not. Okay, so if it's not running, and let's speed of solve. So how fast we'll solve it? So let's solve it 1 second at a time. So 1000 milliseconds is equal 1 second. And on start. So on start, do running is true. We have disabled all the inputs. Okay, and I have created this. So we need to solve it 1 step at a time after a gap of 1000 milliseconds. So we'll use a timeout. Set timeout. Okay, it's timeout of speed, I suppose. Hmm. So if it's running, we will use solver dot solve, and we'll need to do it again, but we need an exit condition. So let's becomes false if it's not able to solve. So we'll keep track of it, and if it does not solve, we'll solve it again. Let's label this timer function to something that's speed. So it will keep on solving it after a gap of 1000 seconds. We'll need a way to pause it as well. So I think timeout. We'll check if it's running or not. If it's running, then solve it. If it's not running, then do not solve. Okay, I think this should be good enough. We need a way to pause it as well. Let's get a button to pause it. It will be button pause. This button will pause it. So let's add let button pause be equal to document get element by id. So when button pause is clicked, add event listener PA. This is click, we will toggle the running variable. Okay, so if it's running, then the running is equal to not running. Just to toggle the running variable. Do we need to toggle it? Sure. So when we click on start, is start. Okay, let's call test tab function as well, so it populates itself. So start. So it has populated itself, and it starts solving it by itself. If we pause it, we can resume it as well, I think. I don't think resume, but I think this is good enough for now. What should we do next? Now we have got a solver function as well that's solving itself. Now we need to visualize it, and to visualize it, we'll need to use some colors. Let's work on some colors now. Let's see, we will use the green and red colors. So green for correct and red for incorrect. Okay, let's see. Let's create some new variable colors. We'll use, let's say, green. And let's do something like green RGB0000. This is green. And we'll use red background. We'll use these two colors. We'll add the colors if you want. And if it's why doesn't this work? Do not use empty users. Okay, if it's red, we will use the background color of red background. And if it's green, we will use background color green. But where do we add them? We need to add them somewhere in the Sudoku itself. So when we are checking, so here's a code to check. So if, for example, the box indexes, it finds an index that is causing an issue. So we'll add something like this. How do we add I change CSS of this? Think about it. So this is an input, so we'll need to add the background to the div. We have got this input and its parent element. We will add to its class list the function called array. Let's see this works. So okay, so this is working. We need to remove it, and then okay, so this is working. We need to improve this button. So let's create a function called highlight so that we don't need to do this again and again. Highlight. So highlight will take an index where it has to highlight. But I think we will highlight the entire box if it's something wrong with the box, if it catches something in the box, or we will highlight the row if it catches something in the row, or highlight the entire column if there's something wrong with the column. So we'll need a list of indexes as well, and then which highlight to do. Okay, let's create a constant called highlights. Constant states. Okay, let's put two states. So I have two states called. I don't know if JavaScript does enum. I don't think there are enums in JavaScript. So we'll have a state called correct, and we'll have state called incorrect. So in the highlight, we'll need to pass the state. So for example, if what is wrong? If the state is equal to states dot, that does not work. Let's see, the state is correct. So if it's correct, we will add the green color to all the boxes. Okay. So to this start, I think all in the list of indexes to highlight and which color to highlight it with. So to each indexes dot for each index, what we will do is we will get the input at that index, and to its parent element in class list we will add green because it's correct, and similarly if it's wrong, to each index or incorrect we will add red. So this is our highlight. Then we need a function called clear highlight that will remove the highlights once we are done. Clear highlight I don't need. I think we'll remove highlights from everything. We don't need to specify any index. So we will iterate over all the inputs. This dot input for each input. We'll go to the parent element of each input and remove from the class list green, and we'll also remove red. So what we will do is whenever we are calling solve, we'll remove all the highlights first. And when all the highlights are removed, for example in the box indexes, we find out that this is wrong, so we will call this dot highlight on the box indexes. I need to add the current index to it as well. So index comma box index is index comma box index is comma state incorrect. Similarly for the row indexes, we will add and similarly for column indexes. What this will do is now if we start solving it, Hopefully when we get an incorrect, okay, it did not work. There's something wrong. So this dot highlight, incorrect. Okay, so let's start again. Let's see what happens. Okay, yes, I want something like this to happen. Yes, it isn't highlighting itself for some reason. It is, it's working to a great extent now. I need to check why isn't it highlighting itself. But we're passing it its own index, so it should highlight it itself. I think this is good enough for right now. Sorry, I'm tired. Okay, congratulations, Epic. We have got a Sudoku solver that is working to some extent. Okay, so I think this gives a good idea of how it works. Okay, now I need to add the green highlight when it's correct. So when do we? Okay, so if the flag is okay, so what will you highlight? You will highlight all the box indexes. This dot highlight. We will highlight our own index. We will highlight the box indexes, and we will highlight the column indexes, and we'll highlight the row indexes as well with the correct state. Let's see if this works. Okay, it did not work. Something went wrong again. There will be an error message somewhere. Index is not defined. Index, so this does not have an index here. It's called IDX. Okay, so it's IDX everywhere. Yes, I saw it work. IDX. So now it should work. Okay, yes. Okay, good. This is good. I think this will finish solving it properly if we haven't missed anything. Let's increase the speed. So it's taking 1000 seconds right now. We will reduce the speed to, let's say, 10 times. We'll reduce the speed. If I do start, let's see how it solves it. Something's wrong here. Let me check my code if I miss something obvious. Okay, so we are clearing the highlights, okay, and if it's disabled we are skipping it. Okay, that makes sense. We'll correcting the distance direction. Okay, we're checking the value, and if value is equal to 9 we are reducing the index, changing the value of current index to blank. Okay, oh yeah, so we need to first do this and then now let's see if it works now. Okay, this looks much better, but I see we don't have an exit condition. So the exit condition will be, I think it should be after, if this dot current index equal to 81 will be the last index of the game, we will return. So this will be the exit conditions. Now what we do is reduce speed a bit more. I need to get this done faster. Let's do this. I think this is working nicely. I think it has gotten stuck for some reason. Okay, so something is wrong. Not keeping track correctly. Something is wrong somewhere. We'll need to, let me check my code again. So okay, yeah, clearing the highlights. If this is the exit condition, we are skipping. Oh, yeah, I think here's something wrong. If the input is disabled, like the input here is disabled, we don't want it to come back over here again. We need to keep it moving in the direction it is traveling in. So we will multiply with the direction. So if it's going back, it will keep going back. Let's start again. Let's see if it gets stuck this time. Okay, I think it's working fine this time. Okay, I think I'm almost done with this. If this works this time, I won't be adding anything else to this. The final product is already present, is already hosted on my Netlify. This live video is only for how to create this. Okay, I think maybe it has no, it's working. It hasn't stuck, but it's slow. Let's wait some time. Okay, yes, it's working. Let's see if it exits correctly or not. I don't know how long this will take. While it's working, I'll send some update on the Discord. It's taking too long. I'm not sure if it's working correctly or not, but I need to wait for it to finish. I can increase the speed as I think. Let me try increasing its speed. We'll need to start again, but I think if I increase its speed by like this, it should do it faster. Or maybe I reduce this timeout thing entirely and keep solving it while it's not solved. Let me create a button called instant solve. That will help me. Button instant solve. Quickly add a event listener to this. Get element ID solve dot add event listener. Okay, so it will use the same logic, but instead of using a timeout, we'll simply do while not solved. Solver dot is something like this. So instant. Okay, it did not work properly. I think it's not linked correctly. Solver, okay, yes. Okay, let's try it now. Doing something, I think. While not solved, solver is equal to solved. So solve should be true according to this condition. When it reaches this condition. Okay, this is bad. Let's do it normally. Let's wait till it solves itself. This works. Yeah, it's taking too long. I need to be sure if it's working or not. We have been live for 1 hour and 12 minutes. And we have got one viewer. Okay, till it solves, let's see if the viewer wants to talk. I'm not sure who the viewer is. It's okay. I do think my logic is all correct. We still need to verify this. Hopefully it will be done soon. But hopefully by this visualization get an idea of how the Sudoku solver works. Oh, it erased everything. It's doing it again. My CPU fan has started. The load is too much on my CPU. I think it's stuck because it's working properly. It's taking its time. I can make it any faster. I don't want to mess with it again, or I will need to start again. It's a difficult Sudoku problem, I think. That's why it's taking too long. I don't think there's much you can change now. Okay, so it's done. I think this is the correct solution, hopefully. I don't think there's anything wrong with this. Yeah, I think this is done. So this is all about the Sudoku solver. I'll show you the finished product as well that I made many months ago. This is how the finished products look like. It has options to reduce the speed and everything. If you try this, I will link this in the description. So thank you everyone for joining. Goodbye.